So here is the question. Before we move to the r sine theta plus minus alpha, so first show that 4 sine 2 theta plus 3 cos 2 theta minus 3 sine theta minus 3 equals to sine theta in bracket of 8 cos theta minus 6 sine theta minus 3. So as you can see here, we have a double angle formula. Double angle here. So we have to use double angle formula for sine 2 theta and also cos 2 theta. So for sine 2 theta, we only have this formula, that is 2 sine theta cos theta. However, for cos, we have 3 different formula here we can choose. So it can be cos theta minus sine squared theta. It can be 2 squared theta minus 1 or 1 minus 2 sine squared theta. So the key for the answer is the one that we need to show over here. So as you can see here, if we check correctly, so if we expand sine with cos here, so we get sine theta cos theta, and it should be the first terms here, because 4 times 2 is 8, so we will get the first term here. And look at the second one. So here it is our concern here. So if we expand sine and sine here, we will get sine squared. So the most suitable one here is the sine one here, that is 1 minus 2 sine squared. So we substitute here 3 with cos 2 theta with 1 minus 2 sine squared theta. Okay, and then back here we have another 2 terms, that is negative 3 sine theta and also minus 3. So we expand 4 times 2, we get 8 sine theta cos theta, and 3 we expand here, so we get plus 3 and minus 6 sine squared theta, and then we also have negative sine theta and also lastly minus 3. So you can see right here, we can cancel out positive 3 and negative 3 over here. And as the one that we like to show, we can clearly see that we have to factorize sine. So the next step here, we factorize sine. So inside here we have 8 cos theta minus 6. So we already factorize sine. So here sine, only sine. And then lastly minus 3 only, because we already factor out sine outside here. So this is the answer, and compared with the one that we need to show, clearly it is the similar one. So we can conclude that we already show the first question. Right, next in question B. So this is the one that using the r sine. So in this case, it is r sine theta minus alpha. So remember step number 1, you have to equate the questions. That is 8 cos theta minus sine theta. So we equate with the one that we need to express, that is r sine theta minus alpha. Okay. Next, step number 2. On the right side here, we notice that this is a compound angle. Okay. So we expand the compound angle formula. So r in bracket. So sin A minus B in this case. So we use sin A cos B. So A is theta. Cos B is alpha. So sin A cos B minus, okay, minus cos theta sin alpha. Okay, I write the formula here if you already forgot. Sin A cos B minus cos A sin B, right? So this is the formula that we use, step number 2. And then the most important here is step number 3, that is to equate and form equation. So to equate and form equation, we have to compare, okay? So look at the term that having a cos here. So the term that having cos here is this one, cos theta. So cos theta, cos theta. So what's the other one that other than cos theta? So that's the one that we want to compare. So if you notice that on the left side we have 8, and the right hand side here we have negative here, and also sine alpha. So we equate this one. To be the first equation, that is 8 equals to negative r. So don't forget r outside here. So negative r sine alpha. Okay. So this would be our first equation. Alright, next we compare the second one. So here we have sine theta. So here also sine theta. So apart from sine theta, the left side here we have negative 6, and the right side here we have cos alpha. Okay, so write down here. So here we have negative at 6, so negative 6 equals to r cos alpha. Okay, so now it will be second equation, right? So after we obtain this equation, we will use these two equations in order to find the value of r and also the angle alpha. So firstly, we find r. So to find r, we have to square the first equation and plus with the square of the second equation. So here we got 8 squared plus negative 6 squared, so equals to negative r sine alpha, so we squared, plus r cos alpha also squared. So here we got 64 plus 36. So the right side here we got r squared sine squared alpha plus r squared cos squared alpha. So the left side here we got 100, and the right side here is r squared. So we notice that r squared here is similar terms here, so we can factorize. So inside here we have sine squared alpha plus cos squared alpha. And also we notice that sine squared plus cos squared here is actually an identity, which is equals to 1. So we can cancel out this one, and it is equivalent to 1. Okay, so if it is 1 here, so we can focus of find out r. So r squared equals to 100. So r we got plus minus 10 kan. Okay, but remember the value of r must be positive, that is greater than 0. So therefore r equals to positive 10 only. Next, step 4. So in step 4, So from this equation 1 and equation 2, we have to find out the angle alpha. So to find out the angle alpha, we will divide equation 1 with equation 2. So 8 over negative 6 equals to negative r sine alpha divide with r cos alpha. So here a and c we can simplify. We got negative 4 over 3 equals to negative, so r we can cancel out, and we got sine over cos, which is tangent alpha. And here both sides we have negative, we can cancel out negative, so therefore tangent alpha equals to 4 over 3. So notice that we have alpha. So we know alpha is between 0 and 90 degree. So the value of trigo function here should be positive. If we got the value of trigo tangent here is negative, so check. There may be some mistake in the equation 1 or equation 2 earlier. Okay. So now we proceed to find the alpha. So alpha is inverse tangent 4 over 3. So to get this value, you have to check with your calculator. So press your calculator. So we got the angle is 53.13, or we can also put 53.1 also acceptable, since it is already 3 significant figures. So after we got the value of alpha, then we can proceed to step number, I think it's number 6. So this one should be 5. So last one, step 6. So step 6 is actually step 1 with substitute of value of r and alpha that you already got. So the original equation, so 8 cos theta minus 6 sin theta equals to r. R is 10 sine. So theta minus alpha. So alpha is positive 53.1 degree. So that's the answer for the second part of the question. Right, so now in the part C, that is the third part of the question. So using the facts in A and B, which is part 1 and 2, solve for sin 2 theta equals to 3 sin theta minus 3 cos 2 theta plus 3. So we move everything here to the left side. So for sin 2 theta, and then we move this one first. So move to the left will be positive 3 cos 2 theta, and then this one 3 sin theta, so it will become minus 3 sin theta, and then lastly positive 3, so bring to the left will be minus 3 equals to 0. And notice that when we compare to the question in the first part, it's actually the similar thing, right? That is, this one we can show that it is equivalent to sin theta in bracket 8 cos theta minus 6 sin theta minus 3. So equals to 0. So when we want to solve this equation, so we notice that we have a factor sign outside here. So the factor sign outside here means that one of the solution is sin theta equals to 0. So if sin theta equals to 0, then the angle, which is theta, so the angle here we have to check the graph of the sine. So the graph of the sine would be like this. So we notice that the situation where the sine theta is 0 is at 0 degree, pi, and also 2 pi. But here our range only cover 0 until pi. So the answer here only 0 and pi. So without 2 pi in this case. So that's the first solution. The other solution would be 8 cos theta minus 6 sin theta minus 3 equals to 0. Or we can rewrite like this and straight away bring negative 3 to the right side. So now it will become equals to 3 itself. And also notice that this one we actually calculate in part B. That is, it is equivalent to R, which is 10 sine theta minus alpha, that is 53.1 degree. So equals to 3. So bring 10 to the right side. So sine theta minus 53.1, so equals to 3 over 10. Right. So before we got the value of theta, so first we find out the value of alpha, which is inverse sine 3 over 10. So check with your calculator. Inverse sine 3 over 10. So 3 over 10. So we got 17.45. So 17.457, so 46 degree. So in our cases, theta minus 53.1 degree, so equals to 17.46 degree, and also for the second quadrant, because we know silly tomcat. So for the second quadrant, sign also positive. So 180 minus 17.46 degree. So here is 17.46, and the other one here. So we got 162.54 degree. Okay. And then lastly, to find theta, so you have to add with 53.1. So 17.46 plus 53.1. So we got 73.56. And the other angle is 162.54. So we got exactly 180 degree. 17.4. So 53.1. So we got 205.64. So 205.64 is already exceed pi, which is 180 degree. In the previous slide, for the first solution, we already obtained the value of theta, which is 0 and pi. And the other solution, we obtain only one angle, that is 70.56 degree. And the other angle we omit because it is already exceed 180 degree. But look at in the question asks about angle in radian. So since this is in degree, so we have to multiply with pi over 180. So 70.56 multiply with pi and then divide with 180. So we got the angle 1.23 radian. So equivalent to 1.23 radian, which is correct to three significant figures. So therefore, when we combine together all the angles, so the angle would be 0, 1.23 radian, and also pi radian. So that's the answer for this question. So that's all for this video. So I hope you got a better understanding on how to find the solution using r sine theta plus minus alpha. So stay tuned to the next video. Thank you very much.